Oh, yeah. My t should be calculated over here in the loop, not up there. Yeah, thanks. Yeah, t should be updated every step, right? I didn't update my t. My t is always 0, so that's why. Okay, so now it should be correct, right? Right hand side equal to t. T is equal to some updated number. Okay, let me. Yes, it should be I, not in. Thank you. Right. So I is the time step number, not in. In is just the length of the list. Yeah. Thanks. That was my confusion. Now I run it. I have my U. Okay. I think I did reproduce the problem, right? If I plot U, let me just 1 to 100 and OI. Okay. Yes, I did reproduce my problem. So you can see it goes up and down and up and down and goes pretty crazy. It's already 10 to the 34. All right. So now we have an even simpler case. How do we look at the problem? How do we figure it out? So one of the things we can do is we can plot it against a true solution. How about that? Right? We can actually look at the difference between this and the true solution, which is t squared. So let's actually make u is equal to 0 and t. Let me just make t equal to 0. Okay. So here, let me actually just t is equal to t. Let me just append the list to t. So right hand side is the last t. So this will be equivalent, but now we are recording the history of t, right? Where I should remove that. Okay. So we run it, and we should be able to plot both the solution and hold on and plot the t square over 2. And let's do it from 1 to 100. So essentially, we are going to see that the solution, the error actually is basically many orders of magnitude larger than the true solution, right? And it doesn't really matter what the true solution is. So looking back into our formula, right, we are updating the next time step solution from all of these. Now, the nice thing is that we have, I think, who suggested the simple equation? Your suggestion is great because it made this term, right, insignificant. Now, when my solution is 10 to the 34, right, I have a solution that is, this is on the order of 10 to the 34, this is on the order of 10 to the 34, and this is on the order of 10 to the 34. And how about this? This is on the order of delta t, right? 3 delta t times f. So pretty much to analyze why we have this oscillatory behavior that goes bigger and bigger, we can pretty much ignore what f is. On the other hand, which is basically to say we can ignore what equation we are solving. We actually expect the same kind of behavior to exhibit for any equation. It's actually independent of f, right? Even when we have a case that f is not really significant, we still see the error becoming bigger and bigger and bigger. So that helps us focus the problem on not the f part of the equation, but on this part of the equation, right?